Hey guys, so this video is just a summary of 6.3 and 6.4. Unfortunately, we were supposed to finish this entire chapter, this unit on Friday, so we're a little behind. So I decided instead of skipping 6.3 and 6.4, we're just going to combine them together and try to finish as soon as possible so that we're not too behind on the next unit. Anyway, so this is going to feel a little fast, but I promise I'm just giving you guys a summary of what 6.3 and 6.4 are, so you get the gist of it. Okay, so we are given this table. Remember, we call this an input-output table where our inputs are our x values and our outputs are our y values. I'm just going to write that right here so we can visualize it. All right, so they already give you the points, and the first bullet asks us to plot the points given in the table. So let's go ahead and plot these. So my first point is -2, 2. So I'm going to -2, 2. Actually, that's -2, -2. I'm trying to get -2, 2, which is right here. Now my next point that I'm going to plot, I'm going to stay plotting in red. My next point is 0, 3. So I go to 0 on the x-axis and I go up to 3 on the y-axis. Perfect. Now I'm going to do my next 2 points in blue. My next 2 points are 2, 4 and 4, 5. Remember, when you write your points, you always write them x and then y. So let's plot 2, 4 and then 4, 5. Perfect. And my last point is 6, 6. So I'm going to go to 6, 6. Perfect. Now I'm going to connect all 3 of those points. And it makes a beautiful line, which is a linear equation, or it's a straight line, right? There's things that we're going to learn about that are non-linear, so I'm just stressing that this is linear. And it wants us to write the equation. Now, there are 2 ways that you can write this equation. You can just write y equals mx plus b, and you can just ask yourself, okay, what's the slope and what's the y-intercept? So this is probably the easiest way to write an equation if you understand y equals mx plus b. So if I look at where the line intersects the y-axis, that's my y-intercept. So this line crosses the y-axis at 3. So this is the y-intercept, and in y equals mx plus b, b represents the y-intercept. So b would have to be 3 because that's where this line intersects. So I already have one part of my equation. I also have x, and I just need to find my slope. And remember, my slope is rise over run. So slope is rise over run. In other words, the change in y over the change in x. Y, the y-axis either goes up or down, depending if it's positive or negative. The x-axis, you can either go right or left, depending if it's positive or negative. Now, if you just look at this line, you know that the slope is going to be positive because it is increasing. So it's a positive slope. So we don't really have to pay attention to positive or negatives here because we know our slope is going to be positive. We just have to pay attention with how much we go up and how much we go right to get to one point, from one point to the next. So this is how you would use slope. I go up 1, right 2 to get to my next point. Up 1, right 2. Up 1, right 2. Up 1, right 2. And if the line kept going, or if the graph kept going, it would be perfectly lined up to another intersection of these lines right here. Now, what if I go down 1, left 2, down 1, left 2? It's supposed to be right here, but there's human error with my graph. So in other words, I go up 1, right 2. So my equation is y equals 1/2 x plus 3. That's one way to find the equation. Another way you can find the equation is you can take 2 of these points. I'm going to highlight them in blue. Take 2 of these points, these blue points right here. Just pick 2 points. Get 2 points and input them into the slope formula, and that'll get you your slope. So remember, our slope formula was, oops, sorry guys, I'm still writing with the highlighter. So the slope formula is m is equal to y2 minus y1 over x2 minus x1. So the 2 points that I decided to use are 2, 4 and 4, 5. Or you know what? Let's use an even easier point. We have 0, 3. Let's use 0, 3. You can use any 2 points that you're given in the graph. So I could have chosen negative 2 over 2, 0, 3. I said over, but I meant comma. 0, 3, 2, 4, 4, 5, 6, 6. I can use any one of these 2 points. I chose these two. Then you just label them. So I'm going to say that this is my x1, y1, x2, y2. And I'm going to input them into my formula. So I have 3 minus 4 over 0 minus 2. All right. Now, if we do the math, that's negative 1 over negative 2. Negative 1 over negative 2, that's just 1/2. So you found the slope. The slope is 1/2. But they want an equation. So what you would do is you would say y equals 1/2 x plus 3. Because 3 is where the line intersects with the y-axis. Right here. 3 plus 3. Another thing I didn't realize is instead of graphing it, you could have also just picked 2 points, find the slope, okay? And then look at where x is 0, y is 3. So you don't even have to graph it. You could see, oh, when x is 0, y is 3. So it's the y-intercept is 3. 33 and 30. All right, so if the graph is linear, you would see a line, right? So you would see something like this, or you would see something that's graphed like this. Those are called linear graphs. Something that is non-linear, so non-linear is anything that doesn't look like a straight line, like a line. So let's say you have something like this. That's non-linear. Or if you have something like a parabola of some sort. So a parabola is a shape that looks like this. Let me draw it in a different color. Okay, that's obviously non-linear. You can also have something that looks like this. It looks like an upside down V or even a V. They could even try to give you a graph that looks like this. Those are non-linear. Okay. Well, that second one looks like it's a bow and arrow or something. You could also be given something like this. That's not linear. You could be given something that goes like this. That's non-linear. So I think you guys get the point. There's linear graphs and then there's non-linear graphs. Sometimes what they'll do in math, they'll give you a input-output table, and they'll ask you does this table represent a linear graph or a non-linear graph? And then the only way for you to know is if you actually plot the points in Desmos, or if you actually draw it out. Then you can see if it's linear or non-linear. And just so you know, this graph that I just wrote right here, if you were to actually graph it out and put it into Desmos, you would actually find that this is an example of a linear graph right here. So if you're bored and you want to put this into Desmos.com, you will see that it's a linear graph. Actually, there's an even easier way. You don't even need to use Desmos. So let's say you're given something like this, x and y, okay? And you're given 3, 40, 6, 32, 9, 24, and then 12, 16. You can actually try to see if you can see a pattern. And in the x's, I know you guys see the pattern where they're all going by 3, right? You're adding 3 each time. There's a pattern right there. And then there's also a pattern underneath. If you guys caught it, each time you're subtracting by 8 for the next output. So if you can find a clear-cut pattern like that, that's another way to find that the rate of change is constant. In other words, this is linear. And an example of something that's not constant or not linear would be a graph that's like this. Watch. You guys will see that the patterns are not constant, but I just want to give you the example first. So let's say you have 1, 2, 3, 11, 5, 33, and then 7, 88. So each of these changes by 2. Oops. Sorry, I didn't mean to delete that. There we go. So each of these you add by 2. But these, it almost seems like you're adding different amounts each time. So 2 plus what is 11? 2 plus 9. 11 plus 22. Sorry. And then 33 plus 55 is 88. So this is not a constant. It's not constant in the amount that we're adding or subtracting each time. So this is an example of a non-linear table. All right, so you guys aren't necessarily going to have questions like this on your assignment that you're going to see on Wednesday, but I do want you to know how to read this type of graph. So do you guys see how this section of this graph, well, first of all, is this linear or non-linear? Hopefully you said it's non-linear because it's not constant the entire time. It's non-linear because it starts off at a certain rate, then it changes that on that rate, it changes again, changes again, changes again, and then finally changes again. So when the line or the graph is straight like this, we would say that it stays the same or that it's constant right here. Okay, it's not going up or down. It's not increasing or decreasing. It's just staying the same, right? Whereas this curve right here, this is like this is exponentially growing. So this is growing very rapidly. This right here is what we would say increases at an increasing rate. It's a little redundant, but this is like increasing pretty quickly, right? Whereas something that's like A right here, this, we would say that this is slowly increasing at a constant rate because it's constantly increasing just a tiny bit. So it's slowly increasing. Then B is a little bit more, what is it called? It's a little bit more steep. So B, we would say that B is quickly increasing at a constant rate. And we would say constant rate because it's still a straight line in this little section. And then C, we would say it's decreasing at a, I would say like steady or slow pace. For C, it's decreasing, but it's a slow pace. Then D is like rapidly decreasing. So let's go over it starting from A. So this graph, this non-linear graph, we would say slowly increases at a constant rate, then rapidly increases at a constant rate, slowly decreases at a constant rate, and then quickly decreases at a constant rate, and then quickly increases at a constant rate, and then it stays the same, or we could say that it flattens out. Okay, hopefully this all makes sense to you. So I didn't want to write all the words in there, but if you want me to pause it or rewind it, let me know. So let me try to give you an example that's a little bit where you can compare like the sales of two companies. So let's say we have two companies, okay? We're going to call this like a gaming company or like a company that sells games. And then we can say that this company over here is a company that sells like makeup or something. Okay, so let's say the sales of the gaming company went like this. Ooh, kind of went off the graph there. And let's say the makeup company goes like this. And you were asked to compare the sales of these two companies. Well, if I were comparing the sales of the gaming company, I would say, okay, this gaming company increased in sales quickly over time, decreased quickly over time, increased again, and decreased again. And there is nothing constant about the sales that they made. And by the way, this represents sales and the x-axis represents time for both of them, okay? Now, if I were to describe the trend in sales for the makeup company, I would say, okay, this company started off really strong. They increased at a constant rate. decreased at a constant rate and then increased at a constant rate. Whereas there's no constant change here. This one is increasing rapidly, decreasing rapidly, increasing rapidly, decreasing rapidly. This is increasing at a constant rate, decreasing at a constant rate, increasing at a constant rate. And these are both examples of non-linear graphs.